works. Recording in progress. Look at that. All right. So welcome officially to the beginning of the second lecture. I always like to start my lectures by showing you the syllabus, and that's not the syllabus. This is the syllabus. So this is where we are. We're at this lecture. I just remind you that you can go to this and you can study the whole course in advance, and you don't have to just be surprised and shocked every day. Okay, so let's go to where we left off with this basics slide, and I'll go to the slideshow. And we were here, right? All right, this is really annoying. Why can't this go somewhere else? Oh, there it goes. Okay. All right. So what we have here are arrays and array lists. And this first we're working with arrays, Java's built-in arrays. And what we want to do with this routine is we want to remove all even numbers from the array. So the first thing we're going to do is we're going to allocate a variable called num_odd. And we're going to figure out the number of odd elements in the array so that we know how big an array to allocate. So what we do is we go through the loop. We start at the beginning, we go to the end, standard for loop. And we say if the array of I at %2, that's modulus 2, is equal to 1, then the number of odds is ++. Okay, now we know the number of results in our answer. We couldn't save those results as we were going along because we didn't have a place to put them, but now we know the number, so we can allocate this result. Now, the next thing we have to do is we have to create an int n, because these arrays are different lengths, and we have to iterate through them at different rates and come to a different number at the end, right? So I'm going to go through the whole array, the whole input array, but I'm only going to increment this n when I put something in it. Okay, so every time I put something into the result array, I increment the n. And that way, by the end, the last thing that I will do at the end of this, n will be equal to the length of the result array. Okay, and then I return the result array. Does that make sense to everyone? Yes. Always start with your name. Arthur. Yes. Right, so if n is initially 0, right, this puts it to 0, but then it updates n to be 1. So the next time you do this, it's a 1. It starts at 0. Remember? Yeah, and remember we talked about the postfix and the prefix of the ++ operator last class. This is it in action. Any other questions? Now, one of the things I need to point out is the speed of these lectures and the amount of material I cover is driven by how many questions I get. So the fewer questions I get, the faster it goes and the more I cover, which is probably not what you want. Also, here's an important thing, right? A lot of students, their eyes sort of gloss over partway through a lecture. They say, oh, I'll study it later. And they fall behind. And usually they wind up following the pirate's code, right? They fall behind and they stay behind. And you don't want that to happen to you. So don't let yourself fall behind. Make sure you understand exactly what's going on. Okay, having said all that, are there any other questions? Yes, name first. Logan. Okay, so this is what this is doing here. Let me instead of pointing this way, let me do it this way. So int array, that's a type. Okay, we're telling it what type we have. We're giving a name to that type. So this is declaring a variable. New allocates an object. Okay, in this case, we're allocating an integer array, and num_odd specifies the size of that array. That's the syntax for that. This shouldn't be new for you, but yeah, but that's what's going on there. Any other questions? But Logan asked a good question, because I know every time a student asks me a question, I know there's 20 other people who are thinking that question and are afraid to ask it. Okay, being afraid to ask a question is a bad thing for you. It's bad for your mental health. Any other questions? Okay, next slide. So arrays and arrays lists. Lists are simpler. We can allocate the list, we can fill the list, we can return the list. So this is we had a 4-step algorithm before, right? Where we had allocate, we had to first figure out the size of the array before we could allocate it. With an array list, we don't have to do that. Theoretically, that makes it simpler. In addition, we can print an array list directly. You can't print when you do a println of an int array, what it does is it gives you this very helpful thing. It says like, I left square bracket at, and then it gives you a number. And that number is the location of that array in memory. Very helpful, right? Doesn't tell you anything that's in that array, just gives you that address in memory. But an array list will give you a nicely formatted version of the output when you go to print it. Lists use method instead of square bracket. So there's a typo there. Lists us. Lists use a method instead of the square bracket operator to get, set, and add. So we have a get, a set, and an add because we can't operator overload in Java. Lists use size parentheses instead of just the length member variable to determine the element count. So there's an inconsistency there. Lists require the conversion to wrapper types. So lists cannot contain primitive types. They can only contain the wrapper types for primitive types. You remember that? You remember what primitive types are, right? How many of them are there? How many? 8. Good. And so list versus array list complexity, well, we'll talk about that a little bit more later. So here is the same program that we had before using an array list rather than a list. Now, with this one, we don't calculate the size first because unlike lists, array lists have variable length and we can grow them. So what we have is a type. So this is, oops, hold on. We have a type called list, and it has an angle bracket integer. So when you declare an integer array, you say int square bracket or integer square bracket if you like, and that says that you have an array, and the elements of the array are of type int or integer. In this case, you put that inside angle brackets. So there's a different syntax for declaring an array list. Also, there is, you notice that we have list result equals new array list. So there's a little bit of magic going on here. A list is sort of a generic type of list. There could be many different types of list. There's 2 standard ones actually. And I can assign either array list or linked list to that object. It's just sort of a catch-all for those 2. And next, what we do is once we've declared it with no size, we go through and we find each odd number. And as we find that number, we call result.add and then do array.get to get the value. And then we can just return the result and we're done. Any questions on how that works? Always name first. JJ? Right, so the for loop is the same as the for loop we had before, except instead of dot length with no parentheses, we have dot size with parentheses. That's a difference between an array list and a list, or an array rather. And we also, instead of putting square bracket I to get the ith element out, we use a get I. When we use square bracket or get, this is called random access. You can use that to access any random part of the array you like. Does that answer your question, JJ? Yeah. All right. Any other questions? Yes. Drew. Well, the difference between an array list and an array is something we're going to get into very deeply. But for now, right, they're 2 different objects with different syntaxes and different properties. So a list, right, uses square brackets to access the elements. A list uses this other syntax for allocation. An array list uses this one. It has a different declaration for the variable type. It has a different size. I mean, almost every like basic operation is different, but the fundamental thing, the two fundamental things that are different is an array can contain primitive types. An array list cannot. The other thing is an array is of fixed length. You can't change the size of it once it exists. An array list you can grow dynamically. You can just keep adding things on. It'll get bigger as you do it. Because array dot size, we're going through the input array. So this is the input array. That's where we're looking for the odd numbers. We use the result when we do the add. Next question. Okay, so most of you are looking at this and you're probably thinking, why are these two things so utterly different? Well, I'm sorry, they should have made it better. But they're utterly different. And most of you are thinking that the array list looks simpler. And it does have fewer lines of code. But you have to keep in mind there is a trick to this, and that is these are wrapper types for primitive types. So that means the elements are not going to be compared with equal equal, and it means they could be null, right? Whereas primitive types cannot be null, these can. I can fill that array with nulls if I want to. And those little things can come back to bite you if you don't think about them. Okay, any other questions? Yes. Well, the problem with a null, right, is if I do something like, if I go to call a dot equals on two things, and one of them is null, right, I'm going to get a null pointer exception. So if the problem with nulls is if you're not thinking about them, you can wind up with null pointer exceptions that kill your code. All right. So, okay, some basic concepts for classes. All right, so if you want a class that's going to be an execute, that's going to have an that can be executed as a program, you need to have public static void main in there. Classes have special methods which are called constructors, and we'll talk about that more in a minute. They also have fields, and fields can have optional attributes such as public, static, and final. All fields have a type, a name, and an optional initial value, okay? It's good to keep sort of this list of properties in your mind when you're thinking about what a class is. We're talking about what a class is. Now, you've always wrote class hello or whatever, and it was always just sort of magic, I think. But we're going to dive deep into what a class really is. Okay, so classes have fields, and they have methods, and they have constructors that all can be declared inside the curly brackets that comprise the class. The declarations of methods are all going to have optional characteristics like public, final, and static. They're going to be required to have a return type, a name, and an argument list. And that argument list will consist of pairs of types and names separated by commas. Constructors are kind of like methods, except they have no return type, and their name is the same name as the name of the class. Okay, and then a constructor is a special method that gets called by Java to initialize the class object. Okay. Any questions? A lot of you are just thinking, what? So let's just move on. We have two types of fields, and we talked about static being optional. Now, up until now, probably everything that you've done, like with a method has always been static. You just automatically stick that on there because that's what you do. But now it's going to be optional. We're not always going to use static. And so what the difference is, so we're going to have static fields as well as instance fields. Those are the two terms you need to learn how to distinguish. Now, a static field is something that's true generically, whether or not any of the objects exist. And an instance field is something that is per object. So let's think about what this means. So if I want to picture, let's say, the number of houses in a neighborhood, right? That number can be 0, that number can be 1, that number can be 1,000,000, right? It's a number that exists independently of any individual house. The number of houses exists independently of any individual house. So you want to think about the number of houses as being something like a static variable, right? That's something that you don't need any houses to exist in order to have it have meaning or to exist at all, right? That's just a thing that you can have. You could also have the sum of the values of all houses in the neighborhood, which could be, you know, billions of dollars or hundreds of dollars or whatever it is, but it's some amount and it exists independently of any individual house. Now, then you have other numbers, right? Like number of doors and windows. Number of doors and windows is a per house thing. Different houses might have different numbers of doors and windows. Those are like instance variables. Okay, so in this case, what we're going to have is a class. There's going to be one or more instances of that class existing in memory, just like you can have more than one house in the neighborhood. And instance variables will be properties of individual instances, and static variables will be properties that exist independently of any instance. Hopefully that made some kind of sense to you. It's gonna make more sense once we see examples, I think. Static methods can only access static fields. So a static method like a static field can be run and executed even if there are no instances of that object. Whereas an instance method is going to make use of instance fields and data that is particular to an instance of an object. Instance methods have access to keyword this, and keyword this is a special variable which refers to the current instance or object. Okay. So here is our first class, and in this class, I have an instance field int A and a static field int B, and I have a static int get B method and a public int get A method, which is an instance method. And then I have public first class, which is a constructor. Now you can tell it's a constructor because why? Who can tell me? Yes. I remember your name is Lucian because you're a werewolf, right? You ever see the movie Underworld? Okay. Right. It has the same name, and what else? It doesn't have a return type. Good. You've got to have both those properties. So first class, and it's got empty parentheses, so no arguments. It's going to set A to 3 and B to A. Okay, then I'm going to have another constructor, first class. This one takes an integer A, and it's going to use that to do the initialization. Instead of putting a 3, it's going to call this dot A. Now, I told you about keyword this. In this case, what's going on is I sort of created a bit of confusion for myself, right? Because what I have is I have an instance field named A, and I have a argument named A. These have the same name. So how do I distinguish them? So I can put this dot in front of A to say that I mean the instance method. And if I don't do that, it's going to go with the argument. So what I'm doing here is I'm initializing the instance of A with A. If I don't have another A to cause confusion, then I don't need this to put this dot in front. I can if I want to, but I don't need to. So this is a special method here, public string to string. And what that's going to do is it's going to create and return a string object. Okay, and whenever you want to call a println on your object, Java is implicitly going to call the toString method to convert your object to a string, and then display it for you. In this case, I'm going to say first class is a string. And I'm going to add A, and then I'm going to add a comma, and then I'm going to add B, and then I'm going to add close parentheses. All statements in Java end with semicolon, of course. Okay, then I have my public static void main. Now I declare first class FC. I declare that variable FC, and then I allocate that object with the variable 9. Now, when I print it out, okay, it's going to print out 9 comma 9, right? It's printing out A and B. And when I instantiated the class, I set both of those things. Now I'm going to declare another variable called FC2, and I'm going to use a no argument constructor. And then I'm going to print out both of them. Now, I want you to pay attention to what the output shows you. So the first time when I printed out the FC, I got 9 comma 9. But the second time I printed it out, I got 9 comma 3. Does that make sense? Why wasn't it 9 comma 9? Right. And what's different about B and A? Okay, but yes, B is a static, right? So, which is what I was trying to get you to say, but I think you understood it. So the point is B is a static. So there's only one B. There's only one variable B in all the universe, right here. And there was a B before I instantiated my first object. B existed, but A did not. Okay. After I instantiated the first object, there was one A in all the world, and it belonged to FC. And then after I instantiated FC2, there were two A's in all the world. And they could each have different values, right? A lot of students struggle with the basic concept of static versus instance, so I'm spending some time on it. And I want questions. I know somebody has a question. The first time it's printed out, it's 9 comma 9. Yeah, so the static number, remember, so the first class, think about it like an individual house, right? And think about the static variable B like the number of houses that exist. Anybody who prints out that number of houses that exist, it's going to be the same number because that's the number of houses that exist. There's only one number for that, right? But the number A is kind of like the number of doors or the number of windows or something. So the A is describing a particular instance of the class, whereas B is just generic information that exists independently of the class. Any other questions? Okay, it's important that you understand this. So make sure you get it through your head. The other thing is that I want to point out is that we talk about objects being passed by reference. So FC and FC2 are both references. What they are, they're just sort of pointers to places in memory, right? The FC is not the name of some particular amount, quantity of data. It's just a number pointing somewhere. And I can reassign it. I can say FC2 equals FC, and then they would both be pointing to the same place, and it would be pointing to the same object. All right, so that's another thing that you have to understand about what's going on here. So again, when you look at a piece of code, you want to understand every little character that's in there. You want to make sure you know why every single character and every single line is in there. And if there's something in there that you don't understand, you need to pull that out in the front of your mind and figure it out and either talk to me or look it up online or something. Okay. Classes versus interfaces. So class versus interface. Interfaces are going to be important for the lab. The way I always like to do labs is give you an interface and ask you to implement it. So an interface can have static fields only. It has methods with no bodies. So if I go back and you look at this, right, you have static int get b. The part in the curly brackets is called the body, right? And when I say a method with no body, I mean that instead of those curly brackets with stuff in them, you just have a semicolon. Okay, so they have no bodies. They cannot be instantiated. And an interface can extend many interfaces. A class, on the other hand, has fields, has methods with bodies. It can be instantiated with operator new. It can extend one class at most. It can implement any number of interfaces. And if you don't specify what class it is extending java.lang.object. Okay, so this is just sort of a framework for some of the codes I'm going to show you next, because I think in abstract that might not all make sense. So let's take a look. Here's second class. Now, second class is going to extend first class. Okay, so we use keyword extends here. Second class has a no arg constructor, and second class has a one arg constructor. The one arg constructor calls super A. Now, super is a special keyword that's used when I want to invoke the constructor of the class I'm extending. So what I want to do is I want to invoke that constructor that took a single argument from first class and pass that variable A to it. As I say, if you use this in a constructor, it must be the first thing that you do. You can't do anything before that. All right. My third constructor, I have int A and int B, or int B2. And I use keyword this, and I put parentheses on it. Now, when I put parentheses on keyword this, what I'm doing is I am calling the constructor on the current class that has a single object. So this constructor, this thing, is calling this thing. And this thing is calling this thing. Make sense? Kind of, at least? Yeah, sure. So this, keyword this with parentheses here, that is invoking a constructor on the same class. So this A is invoking this constructor. This constructor is in turn using super, and super is invoking this constructor. All right. If you use this or super in this way, it must be the first thing in your constructor. Okay, so now when I go to instantiate my code, right? First class FC equals new second class. Now here's a funny thing that's going on. All right. Every second class can also be a first class. Remember, it extends first class, so it has all the same methods that first class has. So I can assign it to a variable of type first class. And I can print it out. In this case, I'm printing out, I'm setting 2,4, and it's going to print out 2,4, right? Because I'm setting the A variable to 2 and the B variable to 4. And then I'm going to do a second class. I can use second class as a type also, and I call that FC2. And now I can say new second class 9, 7. And what second class is going to do is it's going to assign A with 9 and B with 7. And so when I print out this second time, B is 7 in both cases, and I have 2 and 9, right? Because 7 is the static, B is the static, and it's universal. So, okay, there was a lot in there. Questions? Yes. Name. So what happens is when I instantiate the class, I pass 2 arguments to the constructor, right? So that means it's going to this constructor because this one has 2 arguments. Okay, and it uses the second argument to fill in B. Make sense? Yeah, so this dot and this parenthesis, so this dot is basically to disambiguate a reference to a variable. So here is this dot, right? And what all I'm doing with this dot is I am accessing a variable on my class. But if I put parentheses there, that becomes a method call, and in particular, a constructor call. So whenever you see parentheses, you think some kind of function is being called. Does that answer your question? All right. Okay. So stare at that for just a moment. I want keyword super, keyword this, the concept of a constructor, right? Variable types. A second class is always a first class, right? You can always assign. So this is called a subclass and this is called a superclass. You can always assign a subclass to a superclass type. If I don't specify that you extend something, you extend object, a built-in class called object. All right. Now, let's go on and see what our next class shows us. Okay. So here I'm doing something kind of weird. All right. I'm extending the array list class itself. So I'm going to have this class, which I call array4, and array4 is going to extend array list of integer. Okay. And now I'm going to say public string toString. My toString method is going to make use of something called a string builder. This is a built-in Java object, Java class that you can use for constructing strings. And basically, you can just append anything you want to a string builder. And at the end, you return sb.toString. Oops, darn it. I bumped the button. Ah. That was not what I wanted to happen. Computers. Just bump the mouse button and it decides you want to go crazy. Okay, so here we go. All right, so array4 is our new class. It's extending array list of integer. We're gonna provide a toString method. Now, the array list class has a toString method on it, but I want to override it. I want to change it to be my own version of that. And I put this @override decorator here, and that override is going to check that I am actually overriding a method. I'm actually providing a new definition of that toString method. Now, I don't need to put that there. And if I don't put that there, Java will happily take, if I wrote toString and I reversed the N and the G, I said toStrigen, I put toStrigen, it will happily let me define a method called public string toStrigen. And it won't override toString because it doesn't know, right? But when I say @override, I'm saying, hey, Java compiler, make sure that this actually overrides something somewhere. Okay, so @override is to help you get more information from the compiler, but it is optional. Okay, you don't have to do it. All right, so here I'm overriding my toString method. And what I'm doing with this is every fourth thing I add into my output array, I'm putting a new line. And so I'm just going to break things up into a shorter width output. That's all this is doing. I'm going to say array list integer A1 equals new array list, make a standard array list. And I'm going to say array list A2 equals new array4. And I'm going to use my new improved array class, right? And because it's a superclass, because it's a subclass, because array4 is a subclass, I can assign it to the superclass type. So I can assign array4 to something of type array list integer. And now I can go through this list and add the same number, the I, 0 to 10, to both of them. And then I can print out both objects. Now, when I call println, the Java compiler is implicitly going to invoke my toString method, and I will get this output. So this is the top line. This is the built-in method, right? And this is my revised so-called improved method that I made. Okay. Can you follow all of that? Maybe you can watch the video 10 times after the class is over. All right. You can also write this code yourself and change things around and get slightly different outputs. You should do that. Remember, I told you to spend time programming every day. If nothing else, spend at least 15 minutes every day. Yes. Kobe, can I explain what? Oh, decorators. There really isn't anything to understand. I think we'll only, I mean, well, there's a lot. You could spend a whole course on it probably, but we're only going to ever care about two decorators. And one of them is at override, and decorators always begin with at. And there's a bunch of machinery that goes with decorators, but they're just not part of this course. Yes. Your name? Right. So the two-string method with the square brackets was built into the Java ArrayList class, but I replaced it with my own two-string method, and my own two-string method formatted it differently. So I use sb.append whenever I'm making a two-string and I want something that's not trivial, right? So if I'm just adding 3 or 4 variables together, I probably won't use it. But if I'm going through a list and adding a bunch of things and it's some amount of complexity to it, then I'm probably going to use it. Make sense? All right. All right. So let's take so I've been talking about these things kind of fast and furious, and I've been showing you different examples of classes and things you can do with them. But it takes several of them, I think. Yeah, I know. It takes several of them, I think, before it sinks in. And let's just do this one at the very least. So what this one has is it has a private int value 0, and that means it's hidden. Nobody else but this class can see that value. And it's not static, so it's an instance variable. I could make it private. I mean, you can combine things. You can say public static and so on.